Okay, so in this video, we're going to talk about balancing chemical equations and how we do it. Okay, now let's first, before we talk about how we do it, let's talk about why we do it. Why do we balance chemical equations? What's the point, right? So let's just talk about like the synthesis of water. We know that water, it's you have two hydrogens or H2 plus O2 yields H2O. Now we know in reality, in nature, hydrogen always exists as H2, okay? And the oxygen always exists as O2. So you have two H's, that are basically bonded together, right? So here are my two H's. And then you have these O oxygens that are bonded together to create basically this H2O. Now, when we do consider this, okay, we know through the law of conservation of matter. So I'm just gonna law of conservation of matter. Basically, it's saying that in a chemical reaction, all right, matter is neither created or destroyed. So these atoms are just rearranged. Well, if that's the case, then when you kind of consider this, right, when you see what's kind of going on, and based off of what the chemical equation is showing you, is that you have these two hydrogens react with these two oxygens and you make H2O. So you have two hydrogens here, but you only have this one oxygen. So the question is, what happened to the other oxygen? And so the reason why we balance chemical equations is so that way the equation can meet the law of conservation of mass. All right, so that it shows that matter is neither created or destroyed. So however many number of hydrogens you have in the reactant side, you have, or many atoms you have in the reactant side, is the same number of atoms you have on the product side. So like, for example, here, when we consider this equation here, what we'll do is that we'll put a 2 here, and we'll also put a 2 here. All right, so what does this mean? All right, so when you look at it, having this 2 here is basically saying that we have two H2s. All right, so here is two H2s, okay? I didn't put a number in front of O2, so if you don't put a number here, it's just an understood one. So there's just one O2 here, but then I have two H2Os. All right, so I'm gonna draw another H2O. Now, remember, the law of conservation of matter states that matter or atoms are not created or destroyed. So however many number of atoms I have on the reactant side, I should have that same number of atoms on the product side. And so if you were to count this out, we see that for hydrogen, we have 4 atoms of hydrogen here. All right, good. So look at the other side. How many atoms of hydrogen do we have? Well, we have 1, 2, 3, 4. So we have 4 atoms of hydrogen here. On the left side, I have 2 atoms of oxygen. Well, on the product side, I have 2 atoms of oxygen. So here, basically, kind of, we meet the law of conservation of mass in this case. And so that's when we're looking at chemical equations, we usually add the coefficients for us to help us balance the chemical equations. So let's talk about how we balance them, okay? So now, here's a chemical reaction. We have aluminum that reacts with chlorine, and then we're going to get aluminum chloride, okay? So we have Al plus CO2 yields AlCl3, okay? So this equation here, we say that this equation is unbalanced, all right? And how do we determine if something is balanced or not? So this is the way that we typically, so this is one way I will show you how to balance a chemical equation. In another video, I will show you another way to balance a chemical equation. So this form of balanced chemical equation, we just simply call it trial and error, guess and check. Anyways, so what I'll simply do is I will draw a line where the arrow is, okay? And then I will list out each of the elements I have on both sides of the equation. So on this side, I have aluminum and I have chlorine, okay? And I typically like to keep things in order on both sides. It's just easier to see, okay? So now initially what I'm going to do is count how many of each of these atoms I have on both sides. So here for aluminum on the reactant side, I have one aluminum, all right? And the chlorine, and then the reactant side, I have two chlorines, okay? And I'll do the same thing on the product side, all right? So let me just kind of erase this here. So on the product side, I have one aluminum, and on the product side, I have three chlorines. Okay, so here, if you could tell, if you notice, is that yes, I have the same number of aluminums on both sides, but I have different number of chlorines. So because of that, this is considered to be an unbalanced, as I said earlier, this is an unbalanced chemical equation, okay? Now, what we're trying to do is make it balanced. All right, what do we need to do to balance this? All right, because once it's balanced, then this chemical equation meets the law of conservation of mass, and that's what we want. We want that. All right, and so what we're going to do, we're going to add coefficients. All right, and these coefficients are basically going to be multipliers. Okay, and to the element that, or to the substance that it sits by. All right, so I drew these blanks here, so I'm showing where these coefficients are usually placed. All right, now key note in this one, we never change the subscripts. All right, so we see here we don't have a subscript here, but that's a subscript 1. We don't ever change that subscript. We don't change this subscript. We don't change this subscript. All right, you change the subscript, you're changing the substance in itself. So we leave that as is. All we're going to do is just add coefficients. Now, what coefficients you add? Well, you basically kind of try to count things out and see what you get. So for example, so here I have aluminum, right? So I have one aluminum here, one aluminum here. So we're pretty much good with aluminum. It's the chlorine. So I have 2 chlorines here and I have 3 chlorines here. So I got to figure out, okay, what coefficients can I use in order to make these chlorines the same number? And I typically with balanced chemical equations, we want to use the lowest coefficient as possible. Okay, so looking at this, I have 2 here, 3 here. All right, so then by looking at these numbers, I was like, hey, well, if I can make these chlorines equal 6 on both sides, okay, so like, okay, what number can I use for this case? I have 2 chlorines here to make this 6. Well, I could put a 3 here. By putting a 3 here, what I'm going to do, I'm going to cross this out and I'm going to recount how many chlorines I have. So I have 3 times 2, and I have 6 chlorines. All right, then I could come over here on this side, on the product side, and I'm looking at chlorine. Well, I want this 6 as well. I already have 3 chlorines here. So if I make this 2, okay, I cross this out and I recount. All right, so I have 2 times 3, and this is 6 chlorines. Okay, now, when you add a coefficient, especially when you can't add a coefficient to a compound, you have to recount each of the elements within the compound. So for example, I have this aluminum here. All right, because I put a 2 here, I have to recount how many aluminums I have. I no longer have 1 aluminum. How many aluminums do I have? I have 2. Okay, and that's okay. All right, we could probably go back and maybe change the aluminum on the other side. So when we're looking at the other side, all right, I have 1 aluminum here. Since there's 2 here, I want 2 on the reactant side as well. All right, so I could place a 2 here, and this will give me, so now I recount this, I have 2 aluminums. Now, if we look, do we have the same number of each of the elements? Yes. Aluminum has 2, aluminum has 2 on both sides. Chlorine has 6, chlorine has 6. And you go back and just check, look, 2 aluminums, 6 chlorines, 2 times 3, 6 chlorines. So this is a balanced chemical equation. So when we look at this, you have 2 ALs plus 3 Cl2s yield 2 AlCl3. All right, so let's look at another equation. All right, so here we have barium hydroxide reacts with NH4Cl, so ammonium chloride, and it yields BaCl2, that's barium chloride, plus NH3 is ammonium, and you make some water. Okay, so we're looking to balance this chemical reaction. So first, let's just see if it's, Well, first we got to figure out if it's balanced or not. So we'll draw a line where the arrow is, okay? And we'll list out each of the elements we have on both sides. So I know this seems a lot, but this is how we do it, okay? So we have barium. With the barium, we have oxygen, hydrogen, nitrogen, and chlorine, okay? And I like to keep the same order on both sides. It's just easier. Okay, so how many bariums I have this side? I have 1. How many oxygens? Well, I have this 2 here. So 2 and the O is inside, so I have 2 oxygens. All right, once again, same thing here. I have 2 here. And I got this hydrogen here, so I have 2. How many nitrogens I have? My nitrogen is here, so it's 1. How many hydrogen? Oh, actually, let me go back. I did mess up on the hydrogen part. We actually have more hydrogens, so easy mistake, obviously. I've just made one. So hydrogens, if you see, I have 2 here, but I also have hydrogens here. So 2 plus 4 is 6. So you really have 6 hydrogens. And how many chlorines you have? Well, we only have 1. All right, so that's what we have on the reactant side. Now let's look at to the product side and how many of each we have. Well, barium, we only have 1 barium, okay? Oxygen, our one and only oxygen is here. Hydrogen, we have 3 plus 2, so that's 5. Nitrogen, we have 1, and then chlorine, we have 2, okay? And so now, if you just compare and look at what the numbers that we have on both sides, you could clearly see that this is an unbalanced chemical equation. All right, we have the same number of bariums, but we do not have the same number of oxygens, nor do we have the same number of hydrogens, nor do we have the same number of chlorines. All right, and so our job is to make those numbers the same. All right, so really, as I said, this is kind of like a guess and check. So you just plug in numbers somewhere and just see where it works, how it works, if it works, right? So I'm looking at my list here. All right, I noticed that my oxygens are different. So I have 2 oxygens here, 1 over here, okay? So try to make them the same number. I figured, well, if I make them, I can make them both 2. If that's the case, then I could have this coefficient to be 2, all right? With this coefficient 2, all right? So then means I have 2 oxygens, but this 2 also affects my hydrogen, all right? And so now in this case, I'll cross this out and have to recount how many hydrogens I have in total. So I have 3 hydrogens here, 3 plus, now this you have a 2, so 2 times 2 is 4. So 3 plus 4 gives me 7 hydrogens, okay? So now let's keep on going because obviously we're not quite done yet. All right, so the hydrogens, I have hydrogens all over the place here. And so usually when I see elements that are in more than 2 places on each side of the equation, I like to make it the last thing I'll try to worry about. So I try to balance out everything else first, and then I'll let that be the last thing that I'll try to balance out. So I'm going to skip hydrogen for now and kind of work on chlorine. So chlorine, I have 1 chlorine here, 2 chlorine here, okay? And so what I can do to make this the same, I could put a 2 here. So I'll cross out this 1. I have 2 chlorines, but this chlorine also affects everything that's in here. All right. So now I no longer have just 1 nitrogen. I have 2 nitrogens. All right. I have to recount my hydrogens now. So when I recount my hydrogens, you see that I have 2 times 4 is 8, plus the 2 over here, I have 10 hydrogens here. All right, so then I have to come on this side here, and so you notice I changed the number of nitrogen to 2, so I've got to change this nitrogen as well. So to make things easier, I will just put a 2 here, okay? By putting a 2 here, now I have 2 nitrogens, okay? Now that I have 2 nitrogens, you should also notice that they also changed the number of hydrogens I have. So let's recount how many hydrogens we have. So 2 times 3 is 6. 2 times 2 is 4. And I add these up. So together I have 10 hydrogens. Okay. So now let's look. Is it a balanced chemical equation now? Well, we have 1 barium, 1 barium. 2 oxygens, 2 oxygens. 10 hydrogens, 10 hydrogens. 2 nitrogens, 2 nitrogens. 2 chlorines, 2 chlorines. So everything pairs up. So our balanced chemical equation, we have here, if it's a blank, it's an understood 1. We don't necessarily have to write the 1 if you don't want to. All right, if you leave it blank, we could always do, all scientists will just assume it's a 1. So your 1BaOH2 plus 2NH4Cl yields 1BaCl2 plus 2NH3 plus 2H2O. All right, and that's the balance equation for this reaction. All right, so let's do one more, okay? All right, so here I have C4H10 reacts with O2 to make CO2 and H2O. All right, so let's balance this out. So once again, I'll draw my line here, all right, and I'll list out each of the elements I have. CHO, CHO. And then I'm going to go ahead and count them out, okay? So how many carbons I have? I have 4. How many hydrogens I have? I have 10. How many oxygens I have? I have 2, okay? On my product side, okay, so I have 2. And on product side, I have 1 carbon. I have 2 hydrogens, and I got 3 plus 1. So, 2 plus 1, and then it's 3. So I got 3 hydrogens. Whoa. All right, so now let's go ahead and balance these. So if you notice, I have 4 carbons here, 1 carbon here, so I could add my coefficient 4 here. Okay, so I could cross this out. Now I have 4, but then it also affects how many oxygens you have. So I no longer have just 3. Here I have 4 times 2 is 8, plus there's 1 more here. I have 9 oxygens. Okay, so my carbons are cool. Let's kind of go down the list. So I'm kind of done with this. Let's try hydrogen. So hydrogen, I have 10 hydrogens on the left side. I have 2 on the right side. So let's do a little bit of math. We figure, okay, we need 5. Okay, so I no longer have 2. I recount 5 times 2 is 10. But I no longer have 9 oxygens as well because this 5 affects our oxygen. Okay, so let's recount. 4 times 2 is 8. 8 plus 5 is 13. So now we have 13 oxygens. All right, so then what we're going to do is, all right, so now we just got to fix oxygen because that's all we have left. Now, when we're looking at this, so we only have oxygens on this left side here, and we have 13 oxygens on the right side. And hopefully you begin to realize there's no whole number integer or no whole number coefficient that we could use that would give us a balanced chemical equation. So when you get to a point where there's nothing that you could really do, basically all you can do is erase and start over. All right, and that's why I said it's trial and error. We're trying to figure this out. We realize these numbers do not work. All right, so we got to use different set of numbers, numbers that will help us to get a balanced chemical equation. Can we get a balanced one? Yes, but it might take a little bit more work than sometimes we originally think, and that's why this portion is called trial and error, because we're really just trying, and if it works, great, and if it doesn't, well, let's try again, but this time make sure we use different set of numbers. Don't make the same mistake, because if you use the same set of numbers as the first time, you're going to get the same results. All right, so obviously I tried to put in 4 then originally to try to make things work, so it didn't work out this way. Let's recount. So we have 4 oxygens, 10 hydrogens, 2 oxygens, 4 carbons, I'm sorry. On this side, you have 1 carbon, 2 hydrogens, 3 oxygens. All right, so the first time, really, we just left the C4H10 as a 1. So I'm actually going to put a 2 here this time. All right, and just to see what happens. So by putting a 2 here, I changed the number of carbon to 8. Okay, but I also changed the number to hydrogen, and now I have 20. Okay, that's the case. If I go into the right side of the product, all right, and I want these two to be exactly the same, so I will put an 8 here. By putting an 8 here, I have 8 carbons. Okay, now we need to see how many oxygens we have. Well, 8 times 2 is 16, plus this 1 over here, so we got, then we got 17 oxygens. Okay, now let's go and change our hydrogens. Hydrogen, we have 20 hydrogens here. We want 20 hydrogens on the product side. So hydrogen is the only one that shows up here, so we'll put a 10. All right, 10 times 2 will give us 20, but this 10 also affects this oxygen, I'm sorry. So we got to recount oxygen again, like completely start over. So we have 8 times 2 is 16, all right? We have 16 oxygens here. 10 times 1 is 10, so 16 plus 10 gives us 26 oxygen. Now, hopefully this makes things a little bit easier. If you have 26 oxygens on here on this side, then here, since it's the only oxygen is O2, then we just need a 13. 13 times 2 is 26. All right, so let's just double check to make sure everything kind of pans out the way we want it. All right, so it's carbon, yes. Oh, I really don't like that color. So carbon, all right, yes, because we both have 8 carbons, I'm sorry. All right, look at hydrogens on both sides. You have 20, all right. And what about oxygens on both sides? We have 26, all right. So we've successfully balanced this chemical equation. I know it might seem a little bit long, but some of these equations take a little bit more effort, a little bit more time to kind of figure this out. But as I said, it's trial and error. So if you try the first time, you're not getting the right answers, erase your answers, assuming that you could do the math correctly. Erasing answers, and then try a different set of numbers and see what you get. All right. So this is the conclusion of part 1 of balancing chemical equations.